know there's a lot of really interesting advances right now in artificial intelligence, but one of the things that I've seen in my time doing what I do is a lot of failure in adoption of not just analytics, but AI in general. And I think a lot of it has to do with how people are approaching the problems, how they're approaching AI, how they're approaching using data, using technology. So, and a big part of it is about the human. And so today's talk is really going to be motivated around being people-centric in our design. It's going to be looking at intelligent machines, looking at artificial intelligence, but taking a more human-centric approach to how we design. And then we're going to kind of try to look at, by taking that more human-centric approach, how does that tie into being more conscious, how to be less biased in how we design our algorithms. And a lot of today's talk is going to be around various stories that some have probably heard, some have not heard, but just to highlight some of the complexities and why there needs to be additional care. And I love the panel before talking about ethics and responsibility of using AI. That's going to be one of the undercurrents of the talk today. So with that being said, as everybody's in this room, because AI continues to advance at a very rapid pace, but in parallel to that, human-centered design and design thinking is moving like wildfire. Google, Apple really set the stage in driving this forward and how they design all their different products, I'll just say, that they release. But the problem is a lot of companies are still treating these as two separate siloed disciplines that are not bringing it together. But yet there's studies showing out, most recently McKinsey, saying that organizations have seen a 30% productive gain by actually bringing these together by introducing a squad concept. And we're going to talk a little bit more about that a little bit later. Squads, I would even call it just your agile teams and how you compose the teams for doing this. So with that being said, people think of these algorithms and think about AI as we're doing a lot of programming in a black box. We're using machine, we're just pointing to data, and we're creating this artificial mind that is just going to do what it needs to do. It's really not an artificial mind. It's a tool for the mind. You know, if you think about most human knowledge is tacit. A nurse and a mother can look at their child and see this child has a flu by just looking at them. They know. A firefighter knows when a building's going to fall, not because he's assessing the structure of the building that's on fire. He knows how fast it's burning. He's got that intuitive feel. He's been through this before. He knows what it is. So when we start talking about the deployment of AI, it's really about how can we use AI to help these people in some of their decision making? How do we try to pull some of that human experience? How do we pull that knowledge that exists? How do we look at the cultural backgrounds? How do we look at societal background? How do we look at all the factors that would go into how we would look at solving a problem, not just pointing an algorithm aimlessly at data and seeing what happens? So a big talk today, a big part of today to me is about, as when we're designing these systems, these algorithms, it has to be trained. We all know in analytics, it's all about the data you have, how you train it, how you test that. But with AI, a lot of it is about what they can actually observe from the humans. This is a big part of this missing. We have training data, we label that data in certain ways, but they're not actually experiencing it, they're not actually observing the interactions and the learnings that have, and they're not reintroducing that into the model. There's a feedback loop that's missing here in how we are integrating with our end users, our people, with the actual design of technology. There's a bit of a divide. And so AI really, we are doing AI as humans. What AI is doing is allowing us to assess more complex systems at a single time in a much faster way. It's allowing us to just move faster. It's allowing to automate a lot of things. But at the end of the day, it's just a natural extension of who we are as humans. And we're going to talk a little bit more about some of the hype around AI is going to take over the world as well. But one of the things that I think everybody's in here for is AI is going to help us in the long run. AI is going to help humanity. It's not going to hurt us. It's not going to overtake us. It's not going to, take every job that we have. So when we're looking at technology and how pervasive AI is becoming into this, it's super important because we need to understand exactly how we're using the technology, what the impacts are going to be to the specific users, and how are we going to address that? What are the side effects that we don't know of because of some of the things that we're programming into these algorithms? So we need to have some kind of awareness and be able to understand what the interactions are going to be with our people, and how do we bring that back into our design and change how we look at doing our design. From a human-centered perspective, for those who study human-centered design, this is a pretty standard model that's used for that. The big focus for me is around empathy on this, especially with what we're doing. Empathy, at the end of the day, it's our ability to comprehend the situations and the perspectives of others, both imaginatively and effectively. But it's rare that we are going to find a problem that is not intimate or not something that's really important to somebody. If we're solving a problem like that, then it's not something that really is that impactful. So what we're trying to do is, in that empathy, we're trying to find a way, by enhancing our designs, by working with our people to truly understand how we can advance them forward. How can we bring what they really need? How do we understand what's going to be important to them, and how do we drive it forward? So what are the emotional aspects of what they need to do? And how do we provide a passionate laser focus on that human energy that'll propel our solution to the next level, to get people engaged in what they're trying to do, that they know that something has been designed for them that's going to help their job, help them do what they want to do. It's not just something that's been pointed at data to just calculate and run algorithms against. So this is a very agile approach. Obviously, we want to constantly be working with our stakeholders, our users. We want to constantly be soliciting information. We want to quickly test. We want to quickly define what's happening. They say, human-centered design is really focused around staying proximate to your end users. There's a quote saying, if I don't know my user's breath, I'm not close enough. If I can't smell that person's breath, I'm not close enough to that user. That's the level of proximity that we need to have. It also allows us to be a little bit more inclusive. I mean, there's a big divergence right now in how some of this is built because of the divides and how we solicit the requirements or the input we need in designing this stuff. We're trying to take a more inclusive, diverse approach. That can happen from your team composition to who you're out talking to. It's a gap today, which again gets to why you see so much bias in a lot of stuff and why you're seeing some of the horrible headlines with how people applied this. The chatbot that turned racist really quick, right? There's some pretty horrible stuff, and so. But one of the other things that people are running into when they're defining and designing and iterating and prototyping, if I'm a data scientist, an engineer, whatever the right term is for you for doing this type of work, I'm going to program it based on my views, based on my background, based on what I see. I'm collecting requirements, I'm collecting information, but I still have my own unconscious biases. But also, I have my own set of values. And odds are my values are different than your values. Maybe we align on some, so I hope to find what those shared values are. But odds are our values aren't the same. And that's really one of the big goals of AI. If you look at Google's Pair, you look at what Stanford's doing in their human-centered AI group, a lot of the focus is on how do we find those shared values when we're defining and building AI. What are of your customers, of yours, so that way there's less potential room for any bias interjection or any influence you're putting on the underlying algorithm itself. So that's a big thing as well in this whole process, is trying to really understand that. But the more we test, the more we iterate, the more we try, it's no longer really a world of waterfall development. I understand some companies still do it, that's fine, but moving and operating with agility, especially in this space, a lot of organizations have struggled doing data science in an agile way. A lot of it's just excuses for the people who do it. It's easily doable, and we see it done every day. It just takes a little bit more of a discipline and change in the style in which people think. And we all know as researchers, PhDs, scientists, that we like to do things the way we want to do it. So it's a change. But so that's human-centered design. But if we take the human, we put the human in, we start working with them, we start to get to know them, at the end of the day, there's a lot of people still who do not trust the machines, right? They don't trust what's going to happen. I don't want you to spit a bunch of data in here and then tell me, this payment may be improper based on whatever you're doing. I don't trust the algorithms. I don't trust what's happening. So fundamentally, how do you create and establish a more trustful and symbiotic relationship between the human and the machine is one of the key factors here. And you think about when people think of trustworthy people, what are the things you think about? Because what you think about when you trust a person is very different than what you think about when you trust a machine. I want a human who's reliable. I want somebody who maybe has sincerity, somebody who's competent. Yeah, maybe I want somebody who has noble intent. Does a computer have noble intent? Does a machine have intent? Depends on the bias, I guess, put in there. But when people think about algorithms and machines, what are they looking at? They're looking at accuracy. You know, they're looking at consistency, followability. They're looking at things that are totally different. So how do you bring all those different components together to build a better relationship all in? And so this introduces a lot of challenge, especially for people who, again, are on the fence and still afraid that the robots are going to take over the world. So it's how do we as designers, how are we as engineers going to bridge that gap and build teams that are together to move this forward? And it really gets to one of the core themes for me is it's just like a rowing team. You don't go send a data scientist in to go do all the data crunching and then bring in the design person in and give a nice interface or then do the beautification of whatever's being developed. They have to be set lockstep the entire way, moving together, and that's a big gap right now today. I mean, these teams are not in the same department. These people are not even on the same teams. They treat it as almost an assembly line. Go do this, then you come in and make it look pretty for me. So even as a team and how we do it, we have to be moving in parallel, step by step. And there's a learning there, right, with your engineers as well as your designers, that they're learning from each other how they think, how they approach problems, what are different ways that they could look at it. You know, because most people are in this world when they think of AI, it's like, just give me as much data as you possibly can give me. That's all I want. Just give me data and I guarantee you I can tell you whatever I need to tell you. I can figure out the context. I can do whatever I need to do. So just give me the data, and then you know what? We'll have somebody go label all the data to make sure that we know that's a car, that's a sign, that's a, you know, whatever. But what's interesting is even in this exercise, where we are out labeling data or we're finding people label data for us, a car and a sign, that's a pretty simple thing to do. But what if it's more difficult? What if it's criminologists trying to label people who have been incarcerated? Is there more bias there? Is there more room for interpretation? Is there more room for subjectivity? Then I know that's a car. That's pretty straightforward. So this is where, again, we start introducing some of the concepts of if you are going to have people labeling data, if you're going to be bringing new data sets in, who are the experts? What are the domain experts you're bringing in? When you're building your teams and when you're designing this, have you brought in the people who actually know this, who have a history and a background and understand the intricacies of this? Getting back, and we're going to talk a little bit more about the incarceration example, I want criminologists, but I also want people who understand rehab facilities. I want people to understand early childhood counseling. I want to understand a whole variety of factors that go into how I'm going to determine potentially what services I might want to offer to somebody maybe coming out of jail to make them successful as they're reintroduced into the workplace. Maybe I need an algorithm to tell me, should I even release this person? And this kind of sets up the ProPublica story that some may have heard that we're going to talk about in a little bit. But most people in here probably heard about, you know, the whole grand chess master who lost to the machine. What's interesting is Kasparov was talking about afterwards, and everybody's talking about the machine finally beat the grandmaster. It's actually not what happened. What actually happened was there were two amateur chess players, each had 3 computers, and they were putting moves and running through scenarios and simulations against, each of them had their 3 machines, and then they were using that to make the move. But most people just hear it was just him, a machine beating him. The kind of the funny part for me is it was the humans who were doing it, and they were amateur humans. It wasn't 2 grandmasters running on 3 machines. It was 2 amateurs who just were telling that what paths to look on. So what's interesting about this message is you have a strong human, you know, you have a strong human, you have a machine, and you have, you know, weak inferior processes. You're going to lose every time to potentially a weaker human, a machine, and stronger processes. I mean, so it's all in this balance of how we need to design it and how we need to pull it in. So what was those 2 amateurs really did, and how were they not able to capture that within the actual algorithm? We've made advances, technology's made advances with commodity hardware, processing power. So obviously now there's a lot more to where the computer can stand alone and do this. But back when this happened, that wasn't the case. It took that because it couldn't process it. It couldn't do the things it needed to do. And there's a great example here where a bank, basically they were having a challenge with teller lines in a specific branch. Just kept filling up. So he just said, data scientists, go tell us what's happening. Go crunch all the data and just tell us how we can requeue things, how many people we need to add, how do we change the layout of the floor. Just go figure this out. Here's all the data and make it happen. And when he looked at the data, he found out he didn't understand it because it seemed like really anomalistic in what he saw. He said, actually, this has nothing to do with layout. He's like, it actually seems like an efficiency problem. He's like, we have everybody coming to our tellers to get checking account balances. So he started looking through data, and all the executives were like, no, that's not what tellers use for. There's ATMs, they can do other things. Your data's wrong. It's incomplete. So he called up one of his designers who works in the field and said, can you do me a favor? He's like, I want to collect some data. I want to understand what's happening at this specific branch. And they went out and they started working together and designing this. They took the algorithms he was doing, looked at the data he was doing, they started doing field research, started bringing it together. Not only did they validate his case that it truly was that in the end, 50,000 hours a year he was able to recoup because the designer and the data scientists together were able to decide how to offer solutions to get that balance for them in other ways. There were still people who wanted to come to the bank because they're right down the street. There are some people who just happen to be there and they just want to get the balance. So they designed kiosks. They use IVR to be able to go out and provide other techniques for people to just call in and get their checking account balance. So just by a simple thing of looking at how you approach it and design it together, again, the data scientists saw something there, but it was more focused on here something was happening. Bringing the designer in, they were able to solution together. They were able to move something forward together, which is I think exactly what the idea is here because it's a more impactful business venture. Procter & Gamble, amazing story where they decided that we are all about the end user. We are 100% about the end user. So every time we go to implement technology, so this is even out of the space of AI, we're going to bring in a team of 50 people. We're going to randomly select 50 people from the organization, and they are going to be a train-the-trainer kind of concept. They're going to be our champions. They're going to be our people who are going to make sure that we get the adoption we want, whether it's AI, whether it's technology, whatnot. What was interesting was they got these people in, and they trained them. It was exciting, 2-day summit. They go through it all. They release them back into the wild, and adoption doesn't happen. Nothing really happened. They were seeing the same results. They tried it again, they continued to see that the adoption wasn't rising. And they didn't understand it because some of these people were supposedly people that they thought would be good champions for this. But what ends up happening was they pulled in a designer, they pulled in a data scientist. The designer said, well, let's understand kind of what we're actually trying to do. Let's reevaluate what your end goals are. Data scientists, let's pull in all the data to see what's happening and why this potentially couldn't be happening. The data scientist had an interesting background, like a lot of them do, where he actually was in healthcare doing epidemiology studies. So what he did was he's like, you know what, this is really interesting because it's about people talking to people and gaining momentum. What happens if we could take this AI algorithm and make it spread like a disease? So maybe I should apply an epidemiology study to this problem and see, because at the end of the day, what it is a social network. So randomly selecting people maybe doesn't make sense. And maybe the people you think are most influential in an organization maybe aren't. So they went in and applied this epidemiology study like AI was a cancer and to see how it would spread throughout the organization. What ended up happening was they identified people that nobody would have identified. It was people all the way from the executive level all the way down to the low-level consultant who was in the organization. And what was amazing about it was the results were phenomenally better. I mean, the time to adoption increased by 300%. They continued to evolve the model. They continued to evolve the algorithm. They continued to see, they started implementing how to enrich their data by pulling in other streams of whether it be internal chat, public chats within their environment. They wanted every bit of information they could to understand who is most influential in the organization. It's a pretty cool story. They actually coined the term analogous inspiration is what they call this. But it's a very successful story that they still use today. And then One other kind of story about bringing in more of the humor into it, the human into it. Medicaid, Medicare, or any kind of uninsurance benefits, is a big problem in the United States. There's a $145 billion a year problem in the United States where government loses money. Fraud, waste, abuse. It's a pretty big problem. Obama put in legislation, a new act to set up teams to work on this. So a lot of states at the state level started saying, well, we got to figure this problem out too. We now have fiduciary responsibility to make sure that we're doing what we need to be doing. We want to make sure that we are vetting all the people that we're sending money to. But we also want to be very careful that we're not preventing somebody who needs money to actually get their money. And the going story was what's going to happen the first time a senator's son doesn't get a check for something, whether it's a VA affair or SSA or whatever the payment may be, it was going to run rampant. So the state of New Mexico decided, we're going to go ahead and we're going to put in a machine learning algorithm designed to flag unemployment insurance recipients, the ones that we see are high risk, relatively high risk. And again, we're in a statistical world, relative is defined, and what the Federal Reserve here in St. Louis is doing for the United States government is, working very closely with each of the agencies to define and adjust what those relative factors could be in the models that they run. But they built this model, and what they found out was, more often than not, actually 99% of the time, it was false positives, just by looking at the data. I mean, it was some would say it's just poorly programmed algorithms, which probably is the case. More likely for government, it's bad data. That tends to be a big issue. And so they said, okay, well, let's take the data we have available to us. If we can modify the algorithm, but how can we be better instead of potentially putting at risk paying people, not paying people, how can we go ahead and create some kind of different interaction here? So a designer came in and said, okay, what's happening is you guys are running an algorithm when a claim comes in or a specific person is filing for assistance, and you're running it through there and then spitting out a decision. They said, well, what happens if we take that one individual who's really the key decision maker of that payment, and what if we, out in the field for each of these offices when people are there playing, why don't we kind of put a pop-up box? Why don't we nudge them a little bit with additional information? Why don't we change the interaction so it's not just this algorithm? What if we can prompt them with additional information, say this is potential risk, can you collect this information? Or whatever it may be. How can we supplement that experience and still give them what they need to do? And how can that evolve over time? And actually, that's what they did. And they actually increased they increased the number of actual stopped payments from actually being submitted by almost 75% because of how they created the interaction with the specific people who are out in the field at the state office. Again, they were thinking about how do we bring the person into it so it's not just about how do I run an algorithm to do it. So it's just another great example. But as we talked about, one of the bigger problems is this right here. You have big-time people coming out saying the singularity's here, it's going to kill us, right? It's going to take over the world. He became, I know, pretty famous for this quote, saying AI is going to overtake us, and we're going to, lose job. And he's written papers saying that it's bad and why it's bad, and we got to be careful and all that good stuff. But that's not what it is at all, right? It comes to the social responsibility of how we do it. It can be used for bad. It can be used for evil. This is where we have to have the right governance. As Tony mentioned it on the panel earlier today, and Matt Seebeck, around the ethics or responsibility that we have in doing this. So are we looking at all the governing rules? Do we make sure that we have the right teams that are making sure that they're looking for the bias, that we're bringing the diverse perspectives into the mix? So it really is about how are we putting process, procedure, and discipline around AI is really what it comes down to. And I don't know if you ever take the human ever all the way out of AI. I think that's the other thing is people think these robots are going to go off on their own. Yes, they're automated things or chatbots or things that are out there, but at what level do you still have some type of human interaction with it is going to be interesting. I don't know how many people know Carissa from Stanford, but it's a lot of words. I apologize. I know that's not what you're supposed to do on a slide. I just put up there because I love the quote. But basically, one of her big things is technology is moving so fast that it goes in this hype cycle that everybody's heard of because of Gardner, and it gets to the hype. And then people get all excited, they try to jump into it, it becomes over complex, they don't know what to do with it, and then a lot of people pull out of it, and then they leave it to the hands of the technicians just to go make it happen and bring it back to me. And when they do that, they've completely destroyed all possibility of diverse thinking. You lose all the different lenses of life, you lose all the different perspectives that come from different people. Now you have technologists implementing technology for the sake of technology. Because it's cool. I mean, we're technologists. We like the cool new tools. But you've lost all of it. And so her whole mantra around what they're trying to do at Stanford is you have to bring in the human-centered design component to this. Because if you don't be more conscientious about bringing in more perspectives, more people, more thought, it's not going to go well. Because you're not going to be inclusive. Your algorithms will always contain some kind of bias. Will you ever be perfect? No. You can't poll every single person. But there are ways and techniques in which you can work together to help each other and your teams work through that. So I'm going to kind of try to wrap this with one final story. I hit it on this a little bit earlier. So back in the 1970s, the United States government was trying to find a way to help them decide how to decide parole or how to decide to let people go. And then criminologists started studying a variety of variables. But back then, the variables are probably there was 3 or 4 that they mainly focused on. As most people can guess, it was race, it was nationality, it was skin color. It was things that, unfortunately, back in the 70s, that's where the focus was. And what ended up happening was they were using this tool, and then a different set of the wing of government came in and said, this is wrong, we can't be doing this, there's no way we can be using computers to decide this. So they completely banned it. And they said, now we're going to complete mandatory sentencing. And then it came back again a little bit later saying, well, we have mandatory sentencing, we're not allowing for parole, our prisons are overflooded, we're spending lots of money, we don't have enough time and money to take care of the facilities, what are we going to do? Then risk modeling came back into place. So now risk factors came in. There was a company, a consulting company, North Point, who went out and said, we're going to build an algorithm that takes in a set of data that is going to help, at minimum, it's going to help these judges decide if they release somebody back into the work world and try to help them, we want to at least tell them what kind of services would be most beneficial to this person. So if it's an alcoholic who gets drunk driving, if it's an abusive spouse who got thrown in jail for that, it may, based on a rating of, do they think this will happen again? What's the likelihood of relapse? We're going to recommend AA counseling. We're going to provide services around, anger management, whatever. So they built this algorithm to be a tool for the judges to say, this is how you should decide if you need to provide additional services. What happened was, in traditional fashion, an end user says, well, wait a minute, if this is telling me the likelihood of relapse, I'm just going to use this to determine whether I should give them parole or not. So they took an algorithm and they took a tool that was not intended to be used in that way at all, and they repurposed it. And judges started using this tool to decide whether a person should get 18 months and go in parole or somebody's there for 3 years and gets parole. The 2 individuals on the screen were ProPublica came in and did a big research on the algorithm because they had this feeling it was very, very biased. The gentleman on your left had committed one crime, went through a convenience store, I think stole somewhere around $87 worth of stuff, got thrown in jail for it. The person on your right had a 5-year criminal history of multiple times, including even armed, and had gotten off on a lighter sentence and whatnot. They put both these individuals into the system, and they could go from a 0 to a 10 a risk factor. The gentleman on your left got a 10. The gentleman on your right got a 3. So it's kind of weird, right? Because, I mean, think of, and somebody in the audience actually was talking to me about this beforehand. The guy on the left who stole like $87, I mean, Winona Ryder stole more than that, and she, was not even an issue, right? She's off running the streets in LA or whatever. But yet, he gets a 10. And it all came down to how the data was being tagged. That was one part of it. Also, it's because of the different variables they were using within their model to actually project this out. So when North Point was consulted, like, hey, you got some serious bias going on, they're like, no, the algorithm's perfect. We can show you the math. It's right. It wasn't at all. They actually found that it was off by about 70%. And so this had affected almost 7,300 people in the California state system from how their lives were. A gentleman who had been molesting children for 5 years went in front of a judge to go for parole. The system rated him at a 3 and said, just get him back out. He's fine. We'll put him into a counseling class because it's a low risk rating. So this is a responsible, ethical use of how we have to do this, and we have to, this is why the team component of this and the people you're bringing in, the domain experts that we've talked about, all those components are super important, and why I fell into the trap in my previous life where it's, just give me all the data and I'm gonna do exploratory analytics, I'm gonna find all the stuff we need to find and we're gonna go. I can tell you where fraud is, I can tell you where waste is, abuse is, I can tell you all the things where we're messing up in forecasting cash flow for the United States government. Like I was just like, give me the data and we'll figure it out, we got smart people. It's not the way it is, right? Because we're just designing blindly. So this is just a very, I think a very true story and a very, hits home for us. I mean, any of us, what if the bias on their side? I mean, as a white man, what if something came up based on my background in where I grew up, and it had me biased for some reason because I'm a hick from Indiana, and therefore I'm more likely to do something. So it's why that's why I love the panel earlier talking about we have to be smart, we have to be ethical, we have to be responsible in how we use this technology because we're the ones designing it, and so we need to put the people first. So I'm open for questions after that. Thank you so much.
This might be total minutia, but were the judges actually just looking at the numbers, or did they actually look at the case files? I mean, did it get to a point where they were just like, you're a 3, you're out?
So the funny part was that this, first off, like I said, it wasn't even supposed to be used for that kind of tool, but what happened was they were defaulting to using the score more than the contextual data around the situation. So that's absolutely right. So I don't want to say they ignored all the context, but in that situation in California, specific to this scenario, they were putting more heavy weighting on the system because they felt it's math, it's data, it tells us I have 70 years worth of data I can go back on, so it's got to be right. So this person came from this region, is this color, has this many tattoos. Yep, keep them locked up for 12 more months because this is ridiculous, right? So no, I don't think I will say it was more heavily weighted towards the analytical technique as opposed to contextual data that they had.
Thank you.
Over here to the left.
When you talk about human-centered and you look at the vastness of 7 billion people and numerous belief systems about what's right and what's wrong, right. How are we going to solve that? What are some of the ideas that are beginning to percolate?
So that's interesting. So that's why you're seeing Google come up with their AI-centered design. That's why Stanford's doing it, because people don't know. Because, again, you start looking at religious systems, you start looking at how you're brought up, your value-based system. People are trying to understand, okay, now we move into this world where we have different models for different types of religious beliefs, different models for how you're brought up, different work styles, work ethic. Do we have different models for different corporations because of certain cultural aspects that they have there? So the question has kind of evolved to, how can we learn and build in a way to take all those intricacies, maybe in a compartmentalized way or in some kind of modular way, but people don't know. It's super complex. And again, even people within the same religion don't share the same values. And I forget the gentleman's name, it was in my slide deck in my notes, but basically said, the goal of AI should be value-based, right? It really should be about our values and what we're trying to do. Because there could be shared values even across religion, across corporations. You know, data privacy is something I hope most organizations are really caring about, right? So there's a value there around some level, but it's massive amounts of money are being funneled into this research right now, and the biggest of the organizations out there are studying it.
One more over here.
You put a quote up which suggested maybe we could have some large-scale, really bad outcome from AI, and you sort of dismissed it, suggesting that sort of the outcome we get will be kind of the aggregate of how good of a job we do at it. Mm-hmm. But offhand, it seems possible the outcome we get will be like a function of what the worst among us do with it. Do you have any thoughts on how to avoid bad outcomes in the presence of many bad and malevolent actors using AI.
Yeah, no, I think that is predominantly one of the big issues right now. I mean, there are bad actors, and that people are going to continue to. You're not going to prevent people who are bad actors from being bad actors in most cases, right? People are. But what we can do is, from a corporation perspective and from that discipline that we want to put around it, the vetting, the cross, I don't want to say paired programming, but how we work with each other and seeing how the model's being built, the data being used, basically challenge that team-based environment. I think there's things like that you can do. I also think that there are probably some, down the road, there will be more regulation that will come into play on a lot of this. I do think government will take a bigger stance in some of this because of some of the implications. I've not done research on it. I can't tell you much about that, but based on my experience in that space over my time, there is already a big dialogue going on around that. So I think I don't have the ultimate answer. I think it's just going to be a lot of deliberate attention, focus, organizations standing up saying, I want to put ethics first and foremost. There will be individuals out there in their offices doing nasty stuff, and it's going to be hard. But I think it's going to depend on case by case for sure.
Can we have another hand for Jeremy?
Thank you.